So for number 8, 9, and 10, we're supposed to figure out what kind of triangle would be formed with those numbers. And to figure that out, we use the converse of the Pythagorean theorem. And that's where we plug the numbers into the Pythagorean theorem. And if it's equal, then it's a right triangle. If it's greater than, it's an acute triangle. And if it's less than, it's an obtuse triangle. So for number 8, 7, 8, and 9, first of all, yes, it is a triangle. You can test to see if it's a triangle by looking at 7 and 8. Those are the smaller two sides. If we subtract them, we get 1. If we add them, we get 15. So the third side has to be between 1 and 15. 9 fits that criteria, so that would work for a triangle. So if we plug that into a squared plus b squared equals c squared, we get 49 plus 64. 49 plus 64 is going to be bigger than 81. So if it's greater than, it's an acute triangle. So number 8 would give us an acute triangle. For number 9, the three sides are 10, 16, and 25. So first of all, yes, that would form a triangle. Again, if we use 10 and 16, the lower end of the options for the third side would be 6, and the upper end would be 26. If we subtract, we get 6. If we add, we get 26. And 25, that third side, is between those two numbers. So if we plug that into Pythagorean theorem, we get 100 plus 256. That will be less than 625, which is why we have an obtuse triangle. If it's less than, it's obtuse. Number 10 is a little tricky because the sides are 6, 13, and 19. That one's actually not a triangle at all. Remember to figure out if the three numbers would work. Take the smaller two numbers, subtract 6 and 13, we get 7. Add 6 and 13, we get 19. So 19 cannot be one of the answers. It has to be between 7 and 19, not including those endpoints. So this one would not be a triangle.